We are going to start with the basics of SQL injection and its types today and expand further on identifying SQL injections via dynamic testing. A SQL injection vulnerability occurs when a malicious user or an attacker injects special characters into the input fields of an application, and any application that fails to apply a validation or that implements a poor validation technique to its input fields that accepts values is susceptible to SQL injection vulnerabilities. Now, what really happens here is that the malicious inputs injected by the attacker are inserted into a SQL query parameter in the application code, which is then sent to the database server. The database server considers the inserted special characters as SQL commands rather than malicious characters, and as a result of execution of a query that has had user supplied malicious data, sensitive information is fetched from the database and displayed on the front end. Now, let's take a look at the flow. So we have an end user accessing the application from the internet, and the user is supplying malicious characters into the application fields, to be specific, the username and password fields, in an effort to find SQL injection vulnerabilities. Now, this input that is supplied travels all the way down to the database server, and the response is sent back to the user. In a successful attack, the malicious user usually can go all the way down to the database layer, the underlying layers, in specific the database layer, to exploit and extract sensitive information. Now, let's take a look at the different types of SQL injection. Three common types that you can easily identify when it comes to SQL injection are error-based SQL injection, blind SQL injection, and second-order SQL injection. Okay, let's start with error-based SQL injection. So, in an error-based SQL injection attack, the application returns database-specific error messages when a malicious input is supplied. Now, the error message could contain information such as database names, column names, table names, version of SQL class names, or namespaces that are specific to the language in which the application is developed. Now, below is an example of database error message. So all you see here is the application telling us that, or the database telling us that there is a syntax error or a syntactical error due to the values supplied to the username and the password fields. Now, this is a basic database error message, but in some cases, a complete stack trace containing a lot more information is returned to the end user. One example that you can see is shown below. Now, let's move on to blind SQL injection. So, unlike error-based SQL injection, a blind SQL injection exploit occurs by constructing the SQL query in a way that the database engine is made to answer few yes or no questions. Or in other words, the database engine executes Boolean statements. The type of response by the database server allows an attacker to confirm the existence of a SQL injection vulnerability. Usually, an attacker attempts to do a blind SQL injection attack when an error-based SQL injection exploit is impossible due to the application's error handling mechanisms. So, applications might in general choose to display generic error messages instead of database-specific error messages in order to prevent the exposure of sensitive information. So, what a blind SQL injection does is it bypasses the error handling mechanism of the application in itself. For example, consider a simple page that displays the product name and product description given the product ID as an input. So the underlying query will look like the one below, which says select product name, product description from products where product ID is equal to 1. Now, the above query returns the details about the product based on the ID that is supplied. The attacker can now try to inject a query that returns a false value as shown in the example below. Select product name, product description for products where product ID is equal to 1 and 1 is equal to true. Now, all of us know 1 is equal to true is always false, and we have an AND statement preceding 1 equal to 2. So, when product ID equal to 1 and 1 equal to 2 is combined, it's like saying product ID is equal to 1 and false. So, when these two statements are combined, the value is always going to be false. So if the application is vulnerable to blind SQL injection attack, the database server will not return any records in response to the above query, since 1 is equal to 2 is always false. The behavior of the application to different queries will be analyzed by the attacker. So even if the application handles error messages in a proper way, failure to validate input fields can lead to SQL injection attack, and this can be identified by the attacker by performing a blind SQL injection attack. Now, let's look at second order SQL injection. So second order SQL injection vulnerabilities occur when malicious input supplied by the attacker is stored in the database table and is used as an input in a different SQL query in a different place. For example, the inputs username and password supplied in the user registration page are usually stored into the database table, and when the user tries to change his or her password, the corresponding SQL query will be similar to the one given below, which says alter table users, modify password with a new password value, where username is the existing user name which is pulled from the database, which is already stored in the database, and password is equal to current password, which could be a new value. So the username field in general for the above query is fetched from the value already stored in the database. An application that fails to validate user supplied values will end up storing malicious data in the database table, which could result in second order SQL injection attacks. Now, that's a quick overview of SQL injection and its types. To you, it might now feel like you will need to understand how SQL queries work and also have a good understanding of SQL to conduct testing and identify SQL injection. But that is not always the case, and let me help you with it. So I will say you need to have basic understanding of how queries work, but you don't have to be an expert to conduct security testing. So this is where difference between task and penetration testing comes into play. Now, if you want to understand the different types of testing, go back and watch my other video on application security testing types, a link to which is given in the description. Anyways, with a manual or an automated dynamic testing, a type of security testing, you can easily identify error-based SQL injection. Let's look at the steps first and we'll get into a demo later. So when you perform a task, you can simply try and find SQL injection by supplying characters such as comma, semicolon, quotes, etc. to an input field and observe how the application behaves. Now, a complete list of characters, input or SQL queries that you can supply to a field can be found in the SQL injection cheat sheet by Portswigger, a link to which you can find in the description of this video. If the application returns database-specific error messages or exceptions for your input, try and obtain sensitive information from the error message or exception as much as possible to confirm the vulnerabilities. You can also go one step further and carry out an exploit with the obtained information. However, if the application returns a generic error message, you may want to try a blind SQL or a second order SQL injection, for which you should have some understanding of advanced SQL commands. Now, in a practical world, DAST is not usually conducted manually. All types of security testing, for that matter, is conducted using automated tools and then going about verifying the results to find out if what the tool has reported is accurate. That way, you can still identify all types of SQL injection with limited knowledge or SQL commands. Now, some of the application security testing tools in the application security space today are Burpsuite, OWASP, Veracode, 45, Acunetics, Qualys, WebInspect, etc. There are also specific tools that pertain to identifying one particular vulnerability. For example, SQL Map is one such tool which is used to identify just SQL injection vulnerabilities. We'll study more about these tools in the upcoming sessions. Let's skip to a demo session for now. Let's try an authentication bypass using SQL injection. So for me to make this exploit, I must understand how SQL works. Let's see. So what usually happens when you supply inputs at the front end is that these values get added to a SQL query in the application layer before being sent to the database. Say for example, if you supply test as a username and test as password to these fields, I can imagine a query being created in the application layer as below, which says select star from users where username is equal to test and password is equal to test. By default, the application encloses text values within single or double quotes. Now, users in the above query represents the table name in the database, and username and password are column names, and the asterisk that you see here is a wildcard character. which in SQL means to bring all the records from the underlying database table. There are ways to identify table names, column names, etc. via SQL injection, but let's not get carried away with the advanced concepts for now and go with our authentication bypass. Now, what I'm going to do here is assume one of the users of the application would be an admin and try to log in with just the user ID without supplying a password or by supplying a random password. So my query now will look like select star from users where username is equal to admin and password is equal to some random field. Now, as most of you know, with SQL, a double hyphen stands for comments, which means anything after double hyphen will not be considered for execution by the database engine. Now, I'm going to use this powerful character for authentication bypass here. And so I would supply username as admin with a single quote and then double hyphen and some random value for the password. And now I know what my query will look like. Now, don't forget the quotes here to avoid any syntax errors. And the query will look like select star from users where username is equal to admin within quotes double hyphen and password equal to some random value. Now, in this particular case, you can even make an exploit without knowing the username. Let's modify the query again. Let's say select star from users where username is equal to some junk value or 1 equal to 1 double hyphen and password is equal to some random value. So select star from users where username is equal to true is a boolean value that will be returned by the above statement. Username is equal to random value or 1 equal to 1, which is always true, and the DB will pull the first record for which in our case application will allow us to log in as an admin user. So let me explain again. Select star from users where username is equal to a random value or 1 equal to 1. Look at username is equal to a random value or 1 equal to 1. This is always going to return true. And then you have the double hyphen which ignores anything after the double hyphen. So it's like select star from users where true. So the database is going to interpret the query to be true and return the first record in our case and allow us to log in as an admin user. Now, let me give you a useful tip. In a practical world, when you do a dynamic testing, you don't have to manually find the cheat sheet, understand the different commands and inject input. You have the advantage of automated tools that can aid you in testing. Here is a refresher for you. Though I want to talk about tools in a later session, let's just look quickly at SQL map to identify a successful input for the username field for this application. Now keep in mind that input values are also called payloads. Let's begin. For you to run a SQL map, you should in turn have Python installed in your machine. Also, there is a catch here in that the parameters are sent in a HTTP post request and not a get request. We will learn more about HTTP methods and headers in the upcoming sessions. For now, before I can run a scan using SQL map, I would want to capture the request via a proxy and supply it as input to the SQL map. If you want to learn more about proxies, go back and watch my other video on dynamic application security testing, the link to which is given in the video. Now, let me go ahead and capture the post request via Fiddler and copy the request to a text file and call it demo.txt. Okay. As a next step, I'm going to run SQL map against this file. And this is the command that you see here to run SQL map. -r instructs the tool to read the post request supplied in the file, and -p refers to the parameter. In our case, it is the user ID. Now, the tool will continue to run for a few minutes. For now, I just want to skip through these steps and show you what the output will look like. So for the username field, one successful payload is shown here. Technically, what you can do is supply this exact payload in your application input field for a successful exploit. Keep watching as we continue to learn advanced SQL injection attacks and tools.